University. I'm very glad to deliver a presentation for you. Today, I'm going to share with you my research topic of formulation of construction equipment replacement and retrofitting strategies for emission reduction. There are 4 parts in my presentation, including research background, methodology, case study, and discussion and conclusions. Let me start with the section of research background. Construction equipment powered by diesel engines have emitted considerable air pollutants such as nitrogen oxides and particulate matters. Construction equipment emissions have been a major sources of environmental degradation and considerable damage to human health. Therefore, it is critical that contractors shoulder the emission reduction responsibilities through manage their equipment in a sustainable way. Namely, they should incorporate environmental considerations into their formulation of replacing and retrofitting strategies, which traditionally is undertaken only with economic considerations. The challenges posed by excessive construction equipment emissions have been motivating international organizations and governments around the world to initiate policy instruments in recent years. Therefore, contractors are being constrained to act in accordance with the initiatives. The revenues and the costs incurred by participating in those programs change the cash flow of construction equipment and finally have an impact on equipment management. However, traditional equipment replacement models fail to consider its environmental impact, which are used to determine when to purchase new equipment and when to share with equipment, merely under the consideration of economic. With the constraints of environmental regulation and incentives, affecting contractors are faced with more challenging management work. They also need to make informed decisions about when to retrofit which equipment and which emission reduction technologies should be adopted. Traditional equipment replacement models are unable to help contractors to deal with this challenge. With the problem of excessive emissions from construction equipment being widely concerned, it is predictable that more and more programs or policies will be implemented. The need of proposing a model to formulate proper replacing and retrofitting strategies is becoming urgent, which can minimize the costs and or maximize revenues. Other, not only economic, but also environmental considerations. Therefore, this study aims to propose an optimization model with economic and environmental considerations to help contractors make proper replacing and retrofitting strategies for emission reduction. The proposed model can be used to optimize the number of purchased in service salvaged, replaced, and retrofitted construction equipment in its period so that the total cost is minimized. And the emission reduction targets of incentive programs that the contractors participate in can be achieved. Let me move on to methodology. In this part, this study proposed an optimization model with economic and environmental considerations for construction equipment management by employing the theory of interlinear programming. Decision variables and the parameters of the optimization model are shown in these two slides. To take into economic factors, this study includes the cost of purchasing new construction equipment, salvage all the equipment, and operating in service equipment during the planning time. Contractors also must limit the emission level of their equipment according to the requirements of environmental regulations and programs that they are constrained to. Therefore, to take into the environmental factors, this study formulates an emission gap, which is an important constraint in the optimization model and shown in the equation 4. The proposed optimization also incorporates the costs and revenues incurred by using retrofitted technologies to control emission levels under the emission gap. The output of the proposed model includes the optimization decisions of the mix of construction equipment that should be purchased, salvaged, retrofitted, and being in service in its period. The objective functions is subjected to the following constraints. Then let me move on to the case study. This study used an excavator fleet belonging to a construction company located in Hong Kong as a case to demonstrate the application of the proposed model. The planning time in this case study is 10 years. The maximum age of each excavator is 20 years. The fleet have 6 excavators. In table 1, you can see the equipment type. For each equipment type, there are two pieces of excavators, and some information of the excavator fleet are also listed in table 1. The input economic parameters are shown in table 2. In this case, this study assumes that the subsidy level for reducing the subsidy level set by the Hong Kong government for reducing emissions by replacing or retrofitting construction equipment is 6,800 per ton. In this case, this study only considered nitrogen oxide. This is because in Hong Kong, only nitrogen oxide are the main types of emissions among all of emissions generated by construction equipment. In Hong Kong, new imported construction equipment is required to meet the level of US Tier 3 emission status.
1 minute.
In line with this regulation, in this case, the average emission level of the case excavator also limited to this level. The retrofitting cost is from another published report. This is the results by applying above data to our proposed model. You can see want to purchase and want to retrofit salvage excavator. In this section, some key conclusions are summarized. First, environmental regulation and incentive program is with the stated subsidy level in this case study will pose a financial burden on the contractors. However, this financial burden may not be very heavy. This is because about just about 4% of the overall cost is the cost of meeting the environmental requirements of the government. Secondly, the emission reduction target of Hong Kong limited the construction equipment order or at US Tier 3 can be achieved through encourage contractors to replace and retrofit their equipment. That's all about my research. Thank you for your listening and welcome.